Hi. So I gave this talk yesterday at London DroidCon, and I arrived about 12 o'clock this morning, so still a little bit sleepy. Yeah, so I'm hoping to talk to you today about our experience modularizing our application for Immobilien Scout and how we prepared our application for Google Play Instant. Now, one sec. So the mobile economy relies heavily on mobile applications, and most businesses will think about developing a mobile-first strategy very early on in their process. So you probably often heard the concept of a mobile-first business strategy before. And this means that the growth and user retention are often used as measurements of success for our application. So we'll often spend a lot of time on promotion and acquisition. So wherever the user journey starts, it'll often start from a URL. And the URL might come from a referral, social, search, developer swag, or written on a toilet cubicle door. Inevitably ends on the Google Play Store. Now, this is great because the Google Play Store is an incredibly useful tool, and its reliable distribution has brand identity as a source of truth. It allows us to trust this verified source of installation. It's also giving us protection from harmful software with Google Play Protect, which makes sure that all devices are running a verified version of your application. But this comes at a cost, and it's one more step to get your users to your user experience. And we want to try and reduce this friction, unless you're this cat. So how many times have you seen this when you've been trying to install an application? This annoying little progress bar. It's infuriating. So long installation times are the leading cause of frustration when users are trying to install our applications. And the user acquisition funnel is already quite difficult, and we're already getting quite a lot of drop-off here. So when we're causing our users to take ages to install their applications, it's going to cancel it quite often. And actually, with applications over 100 megabytes, you get 20% installation cancellation, and it's a poor user experience. So some companies try and get around this by producing progressive web apps or mobile optimized sites. But this is often clunky and intuitive or require extensive dev time. And it's not as pleasant as a native application experience because you don't get to benefit from having a native Android or a native iOS experience which your developers are familiar with, and your users are actually going to feel alienated if they don't get that. So this is where we have Google Play Instant. Now, instant apps are really small native applications that don't require an installation. And it's ideal if you have an Android team already. So it's managed by Google Play Services and support services, and installs a minimized version of the application in real time and runs with little or no friction to the user experience. So it's introduced in Google I/O 2016 with the concept of Park and Pay. And this is a really cool example because it uses NFC to launch an instant app on your phone, for example, at a parking meter. And you can instantly pay with Google Play. And this is outstanding technology. This is a really good user experience. So this is two years old already. So Google Play Instant is available from Lollipop and upwards, and the SDK was made available to us in 2017. And we could start using this application from this point onwards. Now, there are sort of two flavors of an instant application. You've got the ones that can be launched via URL, and you can have as many registered URLs as you want, and as many registered instant apps for this mechanism as you want. And you can also deploy using the Try Now button on the Google Play Store. You can only have one Try Now because you only have one installed application, and it's limited to the default activity registered in your manifest. You have to declare a default URL in your manifest as well, which looks like this. You can manage your releases through the Google Play Store, and you can actually test your instant app releases as well through the internal test track on the Google Play Store as well. So there are three sort of main topics when developing an instant app that you have to take into consideration. Performance. Because an instant app doesn't automatically improve the performance of your application, but your application needs to be performant to actually have instant apps. So instant apps are by nature instant, clues in the name. And it encourages you to modularize your application from a single artifact into a modularized, distributed, parallel executable function series. And because you have modularized application modules, you can take advantage of parallel tasks and these speed optimizations that come with it. So you might be concerned if you can run an instant app from a URL, you've got native code running on your devices without any sort of prompt or any sort of interaction from the user here. You might be concerned about the security implications. But there have been careful precautions taken to make sure that these are not to be worried about. So for a start, if you're using instant apps, you have to use HTTPS. If you're not already using HTTPS, then you're a bad person. You should not be using insecure traffic at all. And make sure you have certificate pinning as well. This is just the standard for now. If you want to have a login experience for a logged-in user, you have to use the Google Smart Sign-in, Smart Lock, sorry. This is a really helpful API. It actually reduces the friction of the user sign-in process dramatically because it allows you to retrieve credentials from an API that the user has already stored previously. And then you also have to verify the URL in the Play console, and it requires explicit user permission. And if you've ever used Netflix app on Android, you'll experience about how seamless this is when actually going to use it, because you'll just launch the app, and it'll recognize your Google account and sign you in as soon as you press the button. It's really nice. The API call looks like this. This is just a sample from the documentation site. So it's really, really straightforward. There's another sample as well that shows how you actually store credentials. This is just how you retrieve it. If you want to handle payments, you can use the Play Billings library offered through Google Play. This offers fast and easy payments in over 135 countries. And you can use Google Pay for physical goods or services. You also have to use runtime permissions. Now, if you've been developing for Marshmallow and above, you're probably already familiar with runtime permissions. You have the location permissions, which are really useful for an instant app. It actually allows you to benefit from a native experience. And you can still access some of the hardware permissions that make it useful to have a native application, such as the network state, billing, as I mentioned, the camera, instant foreground services. These are only available on Oreo. You don't really have to worry about it too much because it won't apply to you in most cases. But if you need to use it, it's there. Internet, of course, phone numbers, recording audio, and vibration. So with all these security restrictions in place, you can imagine that there are limitations on developing your instant app. So with great security comes great irresponsibility. I heard it in a film somewhere. So to abide by the security, you have to observe these performance limitations. So, for example, maybe you're a horrible person and you want to develop an app where you can mine Bitcoin in the background without the user's consent. I know I'd want to. No dice. You don't get access to background services in an instant app, so you can't have anything that's not in the foreground, and it'll be killed off as soon as the user is no longer using it. This goes the same for push notifications because they rely on background notifications. So you cannot use these. However, there is a beta program available from Google at the moment that allows you to sign up for this. So you have to make sure you justify your use case to Google, throw some salt over your shoulder and sacrifice a goat, just to see if you can get in there. You don't have access to external storage as well, because this could really be a potential memory security leak for your sensitive data. So you can't access anything that would be like, for example, photos stored in common storage. You can't detect which applications are already installed on your device. And it's sensitive. But you still have access to local storage. So you can store things with your internal cache, your internal storage, shared preferences. You can still use your SQLite database, and you can use content providers. You just can't export these content providers because that would be a leak of sensitive information. So cool. Say we've got this fantastic instant application, and your user's using the instant experience, and they decide, wow, I really enjoy this app. I want to install the full application because you've offered them an upselling opportunity. How can you seamlessly migrate them from an instant application to an installed application? So Google offers the cookie API via the package manager. These are just like cookies are handled on the web, and allows you to store data, your application state, from an instant app to an installed app. So you can help migration status across here. And this is available in the package manager API and the support package manager API. So of course, with instant apps, you obviously have a size limit. Instant apps used to need to be less than 4 megabytes. because if your user is downloading this on the fly, then it needs to be instant and as quick as possible. Now, this wasn't a technical limit. It was an arbitrary limit put in place by Google because reasons. But it was felt that 4 megabytes was sufficient to ship an instant app, and this was put as a limit. But in the early beta program, they got a lot of feedback from people that they wanted to actually increase the size limit. So they increased it from 4 megabytes to 10 megabytes. So you can now ship instant apps up to 10 megabytes. Now, you have to separate your modules into such a way where you have a base feature module, which is shared between your different features. So you can have, for example, one instant app that uses the base, or you can have 2 instant apps that use the same base, and that base is shared. So that base APK will be downloaded once, and then only your individual feature modules will be downloaded as and when your user needs them. So you have to distribute your size limit between these APKs. So you could have, for example, a 2 megabyte feature and then an 8 megabyte base feature, or 5 megabytes base feature and 5 megabytes individual feature. However you distribute it is up to you, but it cannot exceed the 10 megabyte limit. So this talk isn't just about what Google Play Instant is, but what the experience we went through when using it. So to do that, I sort of have to give you a bit of a history lesson. So here's a case example that we went through. So I work at Immobilien Scout. I started at Scout 2 years ago, and I joined the financing team there. So we work with connecting users with mortgage providers to provide a very cost-effective mortgage. Because if not sure if you're familiar, buying a house in Germany is horrible. Low interest, but high costs. Needs to offer a better deal. And we have this sort of elusive dream of providing an entire digitized process from start to finish. Hey, got a dream, right? So when I started, we started off with a monolith application. And it's not just backends that have to deal with monolith applications, it's front ends too. We had 2 modules, just 2. One was an app module, which was bloated, tightly coupled, huge, and very difficult to manage. And we had a smaller module that was just Java only. I had a few interface contracts and a few kind of API references here. But most of the implementation was in the main app module. So it had very high, tight feature coupling. So one of the first tasks I had to start off with was location input. Now, location input was already available on the web, and this is if the user wants to put in a location for where they're searching for financing. Relatively simple feature, and we already had this in a different part of the application. So it made sense to try and reuse that. You know, don't repeat yourself, right? Whilst it was logical, it did not help on modularization. It became quickly out of control. It had multiple behaviors, and we introduced a lot of technical debt very quickly. So we sat down with each other as a team, and we thought, okay, so we need to address this. We need to think about how we can handle this and how we can actually manage this going forward. So we need to be able to operate independently with autonomy and confidence that the changes we're going to make are not going to have negative impacts on our application. So to achieve this, we had to work heavily on modularization. So we started an Android guild, and we discussed every week any new concepts, any new libraries, any new architectures that we want to introduce into the application or make changes. And we make sure we agree as a team, as a democratic vote, to make sure that everyone agrees that this is a good idea. So it started off with our dependency graph. The diagram here is from a direct acyclical graph. This is the graph that Dagger will generate. We started off with Dagger 1. And we quickly migrated to Dagger 2. If you've ever experienced this, it is hell. I would not wish this experience on my worst enemies. And I have a lot of enemies. So this heavy use of Dagger components actually allowed us to identify parts of the application which we could inject dependencies to independently. And it made a lot of sense to sort of segregate our application and to even start working on this modularization. So we put a lot of effort into this, and we ended up with a lot of separation between different modules. And we used multi-binding as well to make sure that we could provide different dependencies for different deliverable applications in our application. So this worked really well in our favor. So we went from an application that looked like this, with 2 modules, app and search, to an application that looks like this. Now, it does look quite complicated, and that's mainly because it's really difficult to actually display this sort of hierarchy in a single screen. So what I want to try and demonstrate is there's a sort of unidirectional dependency flow here from app down to the base at the bottom. So you have these base modules at the bottom, which provide the contracts, the interface promises, which are then actually provided by the app modules at the top. So we use Dagger to provide these implementations to the lower feature modules, so that the feature modules don't have to care about the actual implementation. They can just rely on the contracts at the bottom. And this worked really well, because as soon as you create a new application or a new packageable application, you can then just change over dependencies, and you can use stubs or smaller subsets of reporting frameworks or tracking libraries, and you can manage your dependencies really effectively. So this really helped us to get underneath the 4 megabyte limit. So if I can simplify this a little bit and show you what we were trying to achieve, is more of a flat hierarchy. So we have individual feature modules, which are not really aware of their neighbors, and they're highly modularized and independent, which means that we can actually then start having these as independent packageable deliverables. This was achievable as well through using internal Kotlin visibility, because Kotlin's amazing, and it worked really well for us. So without even thinking about an instant app, we'd already achieved this level of modularization, which was awesome. We'd one step closer to getting there. So we had a prime candidate for an instant app. But it made sense to investigate other options as well. So there's Android app bundling, which distributes your application with all the resources that it's needed to actually create an APK and sign it. It does mean that you have to give your signing key to Google, and then Google uses the same internal infrastructure to store this as they do with their own keys, so it is secure. I can understand if you're a bit apprehensive, though. There was a great talk from Benjamin Weiss at DroidCon London. The videos will be available soon. I recommend going check it out. And you've also got available dynamic feature delivery. So it's similar to instant apps, but it's a little bit of a different modular structure, because your modules will sort of sit above your app rather than adjacent to it. So they are packaged as separate APKs when provided to Google, and then it means your first installed application is much smaller, and your users will then download each individual feature as and when it's needed. So great, we'd already made a load of progress, but there was a long road ahead. We still had to work on a lot of things. So we still had to optimize our instant app deliverable. We had to kind of look for optimization opportunities. So you start off with code minification. This is Minify enabled. You can use this with ProGuard or R8. You're probably already familiar with it. If you're not already familiar with it, I recommend going and checking it out, because this will make your APK much smaller. You have resource shrinking. This is in the same sort of parameterized as your Minify enabled. You can optimize your SVG assets. If you're not already using SVG assets, I recommend doing so, because a lot of the time, historically, applications would use rasterized assets, which are PNGs or bitmaps. These are quite heavy on memory, and obviously add a lot of size to your APK. So using SVGs, which are vectors, means that you can then rely a little bit more on the processing power and have these rendered in real time. The biggest benefit here is that they are density agnostic. So it doesn't matter which screen size you're drawing on, and you don't have to package several different versions of your images. You can also run through a optimization of your SVG. The link here is for a app called Avocado. It will simplify your SVGs in a little way, and it works really well. You can also use configuration splits. So if you're targeting different sets of users for different languages, different processors, different densities, you can split your APKs and package them separately. And of course, third-party SDKs. Always be conscious of which SDKs you have in your application. Fortunately, Android Studio comes with an APK analyzer, so you can take a look at your deliverable and break down what is most costly and where you can possibly make some potential improvements. So to cover 2 points of those previous list, I want to mention that you should really make sure your ProGuard or R8 configuration is correct, because I didn't. I was struggling for a long while to try and make sure our 5 megabyte instant application was less than 4 megabytes. And I was going through the analyzer, trying to rack my brain, what is making it so big? And yeah, then I noticed that I had this 1.1 megabytes allocation for RxJava, which had all the processors and things that I wasn't even using. And I was thinking, hang on a minute, I'm supposed to be pro-guarding here. Why are these things actually included in my APK? So turns out I wasn't correctly pro-guarding. The configuration was incorrect. So make sure that you have ProGuard enabled for your individual feature modules and your base module, not just your installed app. It needs to be configured there. So there was a happy conclusion to this. My 5 megabyte application dropped to 2.5, and I was instantly underneath the 4 megabyte limit. Hooray. You might think we found that early on in the cycle. That was yesterday. Cool. So another opportunity for optimization is third-party SDKs. I got a question on Twitter, actually, asking about what was the largest library dependency we had to remove. And I'm not sure about you, but it's mostly reporting libraries. So reporting libraries, I think we have about all of them. Yeah, all of them. So there was another hurdle we had to try and get over as well, and that was data binding. So there was a problem with data binding and base feature modules. Battle going on outside. So there's a problem with base feature modules and data binding that you can't use the two concurrently. So this was a bit of a fly in the ointment moment. We thought that we wouldn't really be able to figure this out. So I was talking with the Android team at London, and we got a bit of feedback about this. And this issue has actually been resolved. So you can enable experimental feature data binding. You can enable experimental feature data binding. And unfortunately, this does give you a big red warning in your build log. It'll say, warning, this feature is unsupported and is highly experimental. Don't use it. But I've had a personal assurance from the Android team that it's fine and safe to use and has been for about a year. So, awesome. You might be experienced as well with accessing your activities through intents, and in which you'll reference your activity directly like this. You'll use the class of the activity, and you'll create an intent. But you can't do this. Not available for instant apps, because you can't reference your your activity directly. Instead, you have to use app links. App links are a sort of subset of deep links, and they are a representation of a URL that is in your application and can be handled by your application that you also own. So, for example, we own the websites immobilienscout.de. And as you can see here, you've got the host, path, and scheme. So because we own this domain, we can then say that this app can handle it. And of course, we have the verification of the APK so that Google knows this is really us. So it's not possible for somebody to try and hijack your URL. This will happen. You might also be experienced with adding intent extras to when you're addressing your calculators. So of course, can't do this either. So how do you pass parameters to your activity? Because surely you don't want just a cold start. You can use your query parameters as you would with a URL. And this is the same as URL, where you might have your typical get parameters. You can also access parameters that are part of the URL itself using the data on the intent. But I'm not sure if you can see what might be most difficult here, or what the problem we're going to have here is that it's nullable. So you have to be aware that you may be provided with no parameters at all. This is if you're relying on query parameters. What I'm going to show you here is a sort of, I'm not quite sure if it's a hack or if it's genius. I think in about a year or a month's time, I'll realize it's not genius and what the hell was I doing. But we have the problem that we wanted to build complex compound objects using these query parameters. So given the scenario, you have a region, and you want to have a location and a label for this region. You have to then do all this checking when previously it was just an intent parameter that could be parcelized or unparcelized this way. So if you're not already using Kotlin, you'll use Kotlin. It's amazing. It's the best thing ever. So this is a class we have, one of our data classes. This is the region. And you notice here that we've got a string for geocode and label as the constructor. And we've also got this companion object with the region, which has a string and label as nullable parameters. Now, ordinarily, if you created a secondary constructor with those parameters as nullable, you would get a JVM conflict, because at the end of the day, it all generates Java code. However, because companion object is a static singleton class, you can actually then have it as like this. And then when you call it from Java, you have to call region.companion.invoke. However, if you're calling it from Kotlin, you can actually use the same API as a constructor, so it looks exactly the same. Like that. much nicer. So, not exactly related to instant apps, but it's a nice little additional bit of tweaking you can do. So, to use instant apps, you have to verify your site, because you need to be able to make sure Google knows that your site is who you say you are, and you are who you say you are. So you have to create a digital asset link, which is a JSON file, and it's published to your website to verify the ownership of that. So this file has to include the signature of your key store. You can use the key tool to find this as you would do in the normal method. You'll often need to use this as well when you're generating your key store to actually upload to Play Store, or to use Firebase and register your API keys this way. And it might look like this. Thankfully, I removed our fingerprint, so no sensitive data leak. Android Studio also comes with an app link assistant that allows you to map all your URL intent filters and add logic to handle this intent as well. And you can associate websites, and it will generate this JSON file for you. So then you can just upload it to your server, and all is fine. Additionally, you have emulator support. So you can test your instant apps, and you can test the app links that are generated here. And this really allowed us to then make sure we were going forward with it. So there's a few examples online. The example from Benjamin Weiss, the Topeka app, this demonstrates how to use instant apps without a URL. So it just has the try now feature. So in Benjamin's circumstance, he didn't have a URL for this app, so he used the try now, and this is now available with Google Play. So you can find it at the Google samples on GitHub. And there's also the Plaid app from Nick Butcher and the rest of the Google team, with Florina and Ben working on this as well. No, I really recommend checking this code out, because it has a lot of architecture examples. They're migrating from using RxJava to, not RxJava, sorry, they're migrating using coroutines and using Kotlin, and there's a lot of nice paradigms that you can then take over and implement in your own app. And they're using dynamic feature delivery as well, so each one of the individual modules is actually raised above the app so that it can be downloaded as and when the user needs. Excuse me. There's also a talk from DroidCon London, which I recommend going checking out. The video is available online soon, hopefully. Yeah, and there's a few topics as well that I recommend checking out. So, next steps. I'd really hope to actually have a demonstratable APK that I could show you for our instant app. But unfortunately, because of some limitations with data binding that we're still trying to figure out, it's yet to be shipped. But this is going to be happening in the next month. We're also going to be working on a try now application, which we're hoping to be shipped sometime before the Brandenburg airport. If you're German, you'll get that. So, thank you. Finished a bit ahead of time, I think.
Thank you very much, Ash. And let's do some questions then. Thank you for posting them on Slido. And let's have a look. So the first one, is it push notifications that are forbidden because of background services? It is not true that they necessarily need background service.
No, it's not true specifically. It's just that they are related, and it was the decision from the Google team to not allow this at first. There is a beta program that you can use background notifications, which then obviously comes to the foreground, but it's not available in your full instant app as of yet. So you're right. It's just that they are similar concepts. So it's more of a security decision rather than a technological one.
Thank you. Do you have any plans to reuse some of modules in your app using, for example, Kotlin native or iOS?
I would absolutely love to. I am constantly trying to persuade our iOS team to use Kotlin, but they keep on talking about this ridiculous thing called Swift. So I would really love to use Kotlin native, and I'm going to be continuing to push this. I'm trying to get our backend team to use Kotlin native as well, so we can sort of share some domain logic here. But I can't say if we have any plans as of yet. It's just something I'd like.
And the next one, can you recommend any tool to automatically visualize dependency graph in your app?
That's a tough one. Now, there are some tools available. I can't remember off the top of my head, I'm afraid. There are some tools available that can map out your Dagger dependency graph. And if you're using Dagger heavily, then this will probably be the best way to do it. Is it referring to dependencies as application dependencies or modular dependencies? I guess not be able to answer, but if it's modular dependencies, I created the graph myself, so I just went through all of our build files and created that. There is a tool that allows you to visualize your application hierarchy, how dependencies are, and it can actually put it into a nice graph. I forget the name of it, though, I'm afraid, but there are tools available. Yeah, that's the best I can say.
And we have a new one. Does Instant App have to go through the same process as standard, meaning no adult content?
Yes, so it's still the same application you have on the Google Play Store. You don't add a new one. You can register your URL links in your installed application, and then as you use app bundling, Google will then distribute this automatically. So you still have to follow the same procedures and the same restrictions that you would on the Google Play Store. There is a separate APK upload to upload a installed app for Try Now, but this is still part of your single application listing. So you'll still have to comply with the same content restrictions, the same survey that you have to fulfill, and the same advisory guidelines and the same privacy policies. These all still apply.
Okay, that's what I guessed. Can you shortly describe how dynamic features work with Dagger?
Tough one.
They are. That's why they are asking.
So this really depends on the modularization of your application. And generally, your application graph or your application component will normally be the highest component you'll have. And that's what Dagger will use to generate all your other components. However, if you have other dependencies which sit higher than app or alongside app, then you can use a different component. So, for example, in your dynamic feature module, you will have a component for that dynamic feature, which would then depend on the application component as a subdependency. So you will manage your dependencies through that, and it would just be a normal dependency down like that. I've not tried it yet with dynamic features, but it's sort of the same as we would handle it with an instant app. You have a different component and a different modules as and when it's needed. You have to be very careful that you don't have module conflicts or dependency conflicts here, because Dagger 2 does not allow you to have the same binding in the same application graph. So you have to then perhaps create different subcomponents. The Dagger team recommends not extending or changing modules. You should change components, so then you can change the overall application structure, architecture of your dependency graph. Hope that was the best answer I can give.
And that is it. So thank you very much, Ash.
Cool.
The next talk will be in 11:40, and we'll talk about web accessibility. Right now we have 15 minutes break, and you can explore our food trucks or enjoy the contest that we are having at the DevFest. Thank you.
Thank you.